Now, by the end of kindergarten, we want students to be able to be fluent within five, including knowing all the number combinations that can make a five. This is one of our story problem types in kindergarten, where if I were to say, let's say, there were five apples on a table, some were green and some were red. What are all the possibilities that there could be? So we want to be able students to have to be able to know all those pairs of numbers that can make a five, and the idea that also we can, if we know those two amounts that make a five, if we take one amount away, it'll leave the other amount. So we want to do lots of activities to explore that. Now, one of my favorite things to do is to play a hiding game with cubes and a cup. So what I'll do is I'll place out for the student some cubes. We'll determine together how many that is. So we'll count it up and say 1, 2, 3, 4, 5. So we know that there are five. I'll have the students close their eyes, and then I will hide some under a cup. Now I'll explain to them that I did not take any away or add any more to it. So if we're seeing two and we know there are five, how many must be under the cup? And then we can check it right away. So it's going to be a game that students even play together. So the idea is we're only using five. We're trying to get that fluency within the five here, and that we're seeing all the pairs of numbers that can make up that five. So that's a cup hiding game. We also can do things with number bracelets. So you can make a number bracelet out of pipe cleaner and some pony beads. Now, in this case, I did a five. I could label this with a five on the side, so we know that there are five. But again, students and partners, one person can hide some of the beads under their hand. So the child is looking at the remaining amounts. If I know there are five in all, and I'm hiding some, but I see three, how many more must there be? Two more, and then the student can reveal it to show and to get that immediate feedback to know for sure that it was that three and that two. Students can then be encouraged to write down those when they are ready to be able to show all the combinations that there are. Another great activity is shake and spill. So if you have two-sided counters, you can shake them and spill them out and see how many turned out being yellow, how many turned out being red. So it's hard to see the color there. So we have some that are yellow, some that are red. Again, you can create a recording sheet where the students are recording all the possibilities of what happened, because three yellow ones and two red is different than three red and two yellow. We want the students to understand that. It's a foundational understanding of the commutative property. So the idea that we could have all red and no yellow, or one red and four yellow, and two red and three yellow, and so on, they'll be able to see the different combinations that happen. So you can create a recording sheet that has all the possibilities on there, and then they can do like a race to the top, where they can be recording which ones happened most often in that activity that they did. So that's called shake and spill. We also can do things. I love having students do a guessing game where I would have my recommend, and we're going to the two-lined 10 and 10, so that I can have the different combinations of decomposing. So if I ask the students, I want you to slide over five beads to the left-hand side, and you can use both rows, what way would you do it? Now, I do it one way. So let's say I did two on the bottom row and three on the top row, and I hide it from them. And then I ask them, okay, what did you do? And some student might say, oh, I could put four on the top and one on the bottom. And I can say, oh, yes, that works. That is five, but that's not my way. And then everyone tries it again a different way. And so in that way, I'm keeping all my students engaged. So I'm not having everyone just guess and then one person was right, because the purpose is I want the students to be exploring all the decompositions all the time and get really fluent with that. So I love these double rec and recs for that kind of decomposing games for all the numbers, actually, from 5 up to 10. We want the students to be able to have that flexibility. Then the next thing I also can picture is concretely, is we can act it out using cubes. So I want to now get into the level of systematically finding out all the pairs of numbers that make up this five. So if I have 5 purple cubes, that might be 5 plus a 0. What if I took one cube away, but I replaced it with a blue one? Well, now we can see 4 and 1. And then I can replace another one, and I can end up having 3 and 2. So I can be building these and showing all those different possibilities of those. Now, the next level of that, which I truly love, are the Cuisenaire rods. So let me just turn on the light here so you can see this color here. So here is the 5 rods. So that would represent 5 plus 0. Then I have, if I took one away from the 5 rod, I'd have the 4 and the 1. So I can see how it's matching up linearly to be the same distance. So 5 plus 0 is the same as 4 plus 1. Now I have my 3 plus 2. And now I have my 2 plus 3. So here we can see where the commutative property is kicking in. With my youngest students, I talked about the turnaround principle. But you can literally see how those same 2 colors are there. They're just changing the order, but yet the total amount is the same. And then we have our 1 and our 4, so the commutative property of the 4 and the 1, 1 and the 4. And then finally, I'm back down to my 5. Well, actually, this time it would be a 0 and the 5. So the idea is we're having our systematic taking one away from one and giving it to the other. The students will notice and wonder how we have an upside down staircase. They can notice how some of the same colors are changing the order. And once you get down to this bottom rod again, so you begin with the size rod, you get systematically down to the bottom rod, you know you have all the possibilities. This will then translate for the students to be able to write that down as expressions on the side, or even as equations if you want to do the equal the 5. So that they can know they have all the possibilities. This will help them out a lot when they're doing those story problems where we have the both add-ins unknown. They're trying to work their way through. Now, finally, visual patterns are super, super important as well. So if you can use, let's say, 10 frames, and so the students are seeing the cards and they're seeing the 10 frame, how many more would make the 10? So if I'm seeing 4 there, how many, sorry, not 10, we'll do the 5. We're trying to make 5. So if I have 4, how many more makes 10? And they can be able to see the amount that's missing. Or if I have 1, how many more makes a 10? I know it's hard to see on that card, but this is a 10 frame on this card. But so being able to use flashcards like that, be able to help the kids visualize the 5 frame and how many more are left when you have a dot filled in. So exploring as much as you can those decompositions of 5. And I really would also encourage you to do that for 6 and 7 and 8 and 9. And of course, we want to make sure we're doing it for 10 as well. So lots of possibilities there.